Okay, so now we're going to look at some square roots here. Probably the most important thing, most important property is this one here. Oops. So when I have the square root of two things multiplied together, then it is the square root of them separately. So to do 500, you can do it in a variety of ways. I could have broken it down like 5 times 100, and then I know what the square root of 100 is. But let's say I didn't know what I was doing. So 2 and 250, 2 and 125, 5 and 25, and then 5 and 5. And then what I would do is I would group pairs together. So then this is square root of 4, square root of, 25. I keep doing that. I think I did that in class too. And then the square root of 5. So then I get 2 times 5, square root of 5. So I get 10 root 5. Which I could have gotten a lot faster if I would have just broken this down into 5 and 100. So you can pull out perfect squares, and then that would work also. Okay, so 25. Square root of 25 is 5, but then there's these y's, right? So this is 5 and 5. But 1, 2, 3, 4, 5. So I have pair here, pair here, pair here. So I have really square root of 25, square root of y squared, square root of y squared, and the square root of y. So then I get 5y squared root y. Make my box better. Okay, and then 98, so that's 2 and 49, 7 and 7. So that's, and then I have 1, 2, 3, 4, 5, 6, 7. Looks like I just like screamed at you, ah! And then B's 1, 2, 3, 4, 5. I think I made that joke in class, but I don't know that many people laughed. Okay, so 2, 2, 2, 2, 2, 2. Okay, so I end up with a square root of, just kidding, 49, square root of a squared, square root of a squared. Let's see, 1, 2, 3, square root of a squared, square root of b squared, square root of b squared, and the square root of 2ab. So then I get 7a cubed b squared root 2ab. Okay, so now when I break down 45, I have to go 5 and 9, 3 and 3, and then I have 5 x's, and then I have 4 y's. So essentially I have 1, 2, and I pair here, and I pair here, and I pair here, so that the numerators stay with the numerators, and the denominators stay with the denominators. So this is root 9, root x squared, root x squared, root x, divided by root y squared and root y squared. So then I get 3x squared root x over y squared. Okay. And then I could always try to reduce my numbers before I go ahead and take the square root separately. In this case up here, my 45x to the 5th, y to the 4th, nothing actually cancels out. Okay. So now when I go down here, I'm left with a square root of, so 18 is reduced by 2 and 9, and then 32 is the same thing as 16. So I have 9 in the top, and I have p to the 5 minus 1 in the top, and I have q to the 7 minus 2 in the top. And then at the bottom, I have 16. So we know what the square root of 9 is, and we know what the square root of 16 is. So I have the square root of 9p to the 4th, q to the 5th, over square root, and I did not make a square root sign, very nice, square root of 16. So my p to the 4th, I have 1, 2, 3, 4, and I have 5 q's, 2, 3, 4, 3, 4, 5. So now I have pairs, 1, 2 pairs of p's, 2 pairs of q's. So I'm left with the square root of 9, square root of p squared, square root of p squared, square root of q squared, square root of q squared, square root of q, over square root of 16, which is 4. So then I get, not an eraser, 3p squared q squared root q all over 4. Okay, and that is it for this lesson.